Assalamualaikum, we are from Group 2 and we will explain about Burj Khalifa building for now and the future operation and maintenance. This is my team members, which is me, Muhammad Hakim bin Muhammad Jinen, Muhammad Nur Rashid Hakimi bin Rashidi, Muhammad Akmal bin Muhammad Nizam, Azika Hanun binti Hamzah, and Nurul Syafiqah Ilya binti Rahmat.
We explain a little bit about Burj Khalifa. Burj Khalifa is the tallest building in the world, located in Dubai, United Arab Emirates. This building height was 828 meter and has 163 floors. This building was designed by the architectural firm Skidmore, Owing and Merrill, with Adrian Smith as the lead designer. One of the best things about this building is this building elevator are some of the the fastest in the world. It can travel at speed of up to 10 meter per generally second. For the design highlight, the building height actually is emphasized by its slender, temperate shape and its Y-shaped floor plan. And overall, the design of Burj Khalifa is a blend of traditional Islamic architecture element and modern technology. Next, we explain about design challenge. For the first design challenge is wind load. The building height and slender shape make it vulnerable to high wind load, which is required the use of advanced engineering technique to ensure its structure stability. Next is foundation. The building foundation needed to be deep enough to reach the stable soil, but also have to be small enough to fit on the small side. The engineer used a rough foundation, which is a type of foundation that spread a lot of the building over a large area. Next is elevator. The building height required the use of advanced elevator technology, including double-decker elevator and high-speed elevator that can travel at speed of up to 10 meter per second. Next is water supply. The building height required the use of pump to supply water to the upper floor, and also required the design of a complex plumbing system to deal with the high pressure. Next is energy efficiency. The building height and the desert climate require the use of advanced energy efficiency system, such as chilly water storage to reduce energy consumption and cost. Next is safety and fire protection. The building height and complexity made it necessary to design and install advanced fire protection system and safety measures, including stairwell pre-circulation, smoke ventilation and sprinkler system. Lastly, building management and control. The building height and complexity required the use of advanced building management system to control and monitor the building system and service, such as heating, ventilation, air conditioning, lighting and security. Overall, design and building Burj Khalifa require a combination of advanced engineering, innovative technology and a strong commitment to safety and sustainability. Migrant workers who were the dominant building labor force. They are concentrated on poor pay and the practice of seizing passport until the duty was paid in full.
Okay, next is the building services of Burj Khalifa building. Okay, the system and equipment used to offer different tasks in a structure such as heating, ventilation, air conditioning, lighting, plumbing and also fire protection are referred as building services. This technology aims to make the occupants of the building feel safe, secure and comfortable, just like the Burj Khalifa building. Okay, the first building services is the building transportation. The Burj Khalifa highly developed elevators and escalators were created with the needs of the building occupants and guests in mind. The structure features 57 elevators, including some of the fastest single-deck and double-deck elevators in the world. The elevators allow passengers to move rapidly and effectively across the building at a pace of up to 10 meters per second or 22 miles per hour. Additionally, there are also 8 escalators in the building that connect its various levels. The escalators have emergency stop button, handrails and stairs that are skid resistant because they are made to handle heavy passenger traffic. Okay, next is about security. To assure the safety and security of the building's occupants and visitors, The Burj Khalifa has a cutting-edge security system with a number of cutting-edge technologies. The CCTV camera network, which includes cameras in the entire building, including common space, elevators, and parking areas, is one of the main elements of the structure's security system. Real-time building surveillance is provided by these cameras, and recorded video can be used to look into potential security incidents. Overall, the Burj Khalifa security system is created to offer both inhabitants and visitors a high level of security, and it is continuously reviewed and modified to ensure that it continues to satisfy those needs. The number 3 system is hatchback system. The Burj Khalifa hatchback system, which provide heating, ventilation, and air conditioning for the building occupant, is intended to give them the most comfortable experience possible. The system controls the temperature, humidity, and air quality in the building using a combination of mechanical, electrical, and plumbing system. Utilizing a central cooling system that uses treated sewage water to lower energy usage is one of the hatchback system's primary characteristics. And a number of air handling units that are dispersed around the structure are also a part of the hatchback system. These systems are in charge of regulating the building's temperature, humidity, and air quality. And lastly is the electrical and plumbing system. The Burj Khalifa boasts a cutting-edge plumbing and electrical infrastructure that was created to accommodate both the needs of the building occupants and also tourists. The electrical system of the building has several backup generators that can supply electricity in the event of a blackout, and a lighting management system that can automatically change the lighting level throughout the building depending on how much natural light is coming in. And the Burj Khalifa has an extremely sophisticated plumbing system. Every apartment in the building has access to clean, secure drinking water thanks to a central water filtering system. The building also features a central sewage treatment system that processes and recycles the wastewater, which aids in lowering the building water usage. Next is about the technology that highlight of the current system used in the building. Firstly is the Building Automation System (BAS). Building Automation System (BAS), which is present in the Burj Khalifa, is intended to manage and operate the numerous building services and systems including lighting, hatchback, and security. The BAS is a computerized system that can monitor and operate the building system in real time, and is intended to offer the occupants and visitors of the building the highest level of comfort, energy efficiency, and also safety. The building security system, including CCTV, cameras, and access control system, can also be monitored and managed by BAS. The occupants and visitors of the facility can benefit from this by feeling safe and secure. The central water filtration system, the central sewage treatment system, and also the central cooling system, and the elevators and escalators are just a few examples of the electrical and plumbing system that can be monitored by the BAS. And by doing so, it is possible to contribute to the maintenance of the system effectiveness and efficiency, as well as the prompt detection and correction of any flaws. Next is the smart elevator. The Burj Khalifa elevator system is extremely sophisticated and effective, and it makes use of smart technologies to enhance the elevator experience for both building occupants and guests. The structure features 8 escalators and 57 elevators, among the quickest in the entire globe. The elevators also employ a group control system which enhance efficiency by enabling numerous elevator cars to function as a single unit. With the aid of the system, the elevators may respond in real time to demands of the building's residents, and can also reroute elevator cars on their own based on the amount of people waiting at each floor. 3 is water harvesting and recycling. Water recycling and harvesting equipment is installed in the Burj Khalifa to lessen the amount of water used by the structure. Grey water or water used in sink, shower and other non-potable purpose is collected, treated and reused by the system. The purified grey water is then reused for irrigation and other non-potable purpose in a water treatment facility situated on a building's lower level. In order to use less energy, the central cooling system of the building also use treated grey water. The cooling system can meet the building cooling requirement even in Dubai sweltering summer months because it is built to give maximum comfort for the building's residents. And lastly is smart lighting. The Burj Khalifa is outfitted with a smart lighting technology that regulates the building's lighting intensity based on how much daylight enters the structure. This lessens the building's total environmental effect and energy use. Additionally, different lighting levels can be controlled for various parts of the buildings thanks to the smart lighting system. For instance, the lighting levels in public space like hallway and lobbies can be adjusted to be brighter than those in private space like office and apartments. This saves energy while also ensuring that the building is constantly well lit and secure.
Next is identification of problem related to current operation and maintenance. First, key cards don't give access to facilities. It is the world's tallest skyscraper and is located in one of the cities with the greatest population growth rate. The Burj is known for its white glove treatment, but many of the 1,000 ultra-chic apartment dwellers find that it falls well short of their expectation. Some people have been discovering that their key card do not grant them access to amenities like the gym, the pool or the tennis courts. According to local news this week, some local worry that eventually even the elevators could be prohibited. Second, it doesn't have sewage system. The Burj Khalifa, while unquestionably spectacular, is not connected to the city's sewage infrastructure, so it has to come up with resourceful but revolting technique to evacuate its effluent. The building waste is transported to the glistening tower by a fleet of real poop trucks every day. The most odoriferous battalion possible is then used to take this trash outside of the city. Dubai was still feeling the effect of the 2008 economic crunch when the Burj was finished. Thus, it was judged that linking it to the city's already overburdened wastewater infrastructure was a needless waste of money. The developers believe that transporting the garbage away daily would be less expensive than completing the necessary upgrade to the short-ton sewer system. However, with a potential resident population of 35,000, the structure has the capacity to produce an outstanding 15 tons of sewage every day. Third is safety during disaster. Safety became a top concern with a structure of the Burj Khalifa size, which can accommodate up to 12,000 people at once. The ability to reach a safe location in the event of a fire or other emergency is a significant issue that frequently arises in the Burj Khalifa. Because it is totally absurd for someone to have a decent 160 stories in the event of a fire, the Burj Khalifa's architect installed pressurized air-conditioned refuge rooms every 25 floors. Moving to building operation and maintenance challenges in the future. Every day, facility managers are occupied with making sure the operation of the building they are responsible for operate well. For the building environment system to function at their best, various levels of periodic intervention are frequently needed. This in and of itself presents a number of difficulties, ranging from straightforward everyday interventions to intricate problems requiring several parties. First, cost management. One of the biggest difficulty in building maintenance continues to be cost management. As a result, facility managers frequently find themselves needing to continue providing high-quality service despite financial limitation. They must accomplish more with less resources. Even though it can seem difficult, it is possible. With some preparation and proper resource allocation, costs may be controlled. Facility managers may employ a few key budget components to reduce the overall operating expenses of their structure by closely monitoring them. Second, record and data analysis. Records frequently overtake facility managers. These documents include meeting minutes, stock and asset inventories, repairs and service, and other documents that are produced during regular business operation. Accurate and trustworthy data collection and storage are the first step in maintaining structured record. These data serve as the foundation for strategic decision making. The most widely used technology for this is still Computerized Maintenance Management Software, CMMS, for the time being. The Internet of Things is anticipated to play a larger role in data collection and analysis as smart technologies progress, and CMMS software will be able to pick up on the report that data back. Third, emergency response and safety. The facility management team is in charge of coordinating communication and evacuation in an emergency. Emergency response and safety need proactive and detailed preparation since such situation can range from natural catastrophe to fire, security breach or critical system failure. Any emergency plan should be place a high premium on regular safety exercises and evacuation scenarios. Additionally, regular equipment inspections and reports, particularly automated failure reporting, will keep the maintenance staff informed of any emerging issues. For vital system, this is crucial. The team members should be able to readily examine and evaluate the emergency plan as part of a centralized database. Lastly, extending asset lifespan. Building projects need a lot of resources and the owners will spend a lot of money to make their building and upscale as possible. They aim to keep their structures appealing and competitive in the market. However, this system will degrade as the facility becomes older. Such degradation may be so severe as to compromise structural integrity. Although complete replacement may be the simplest choice, trying to prolong the asset's life starts from the installation phase and is typically more economical and ecologically friendly.
Okay, I will explain about statement in finding solution to problem in future. The solution is integrate backend system enable everyone with one card. Middleware and API running on virtual machine are used to connect numerous access control systems. According to anecdotal evidence, approximately 1/3 of Class A building occupants use the method. The initial investment may be up to $80,000 and monthly maintenance expense vary depending on usage, but often start in the thousands. Because of the considerable cost, we rarely never see this done in Class B or C building. This strategy is typically only appropriate for extremely large corporations with considerable physical security costs. Okay, next, the solution for it transition to smartphone-based access. Employees may now install a mobile credential on their phone using the new option. The mobile credential is then recognized by affordable readers installed by landlords, tenant firms, and building amenity operators such as parking garage. Employees are not even required to take their phone out of their pocket or bags. Okay, next for the solving problem is alternative septic system. There are alternatives to a traditional septic system for diverting and cleaning water waste from building and safely introducing it back into the environment. Traditional septic systems are ubiquitous, but they may not work for every site. There are several reasons why the traditional wastewater sanitation paradigm may not always enough. Okay, and then lastly, the solving problem is using concrete and plastic insulation for safety and energy efficiency in building design for safety during disaster. Architect and engineering are looking to innovative material to develop more durable, higher quality residential structure that can survive the effect of natural calamities. The use of concrete in the external shell of a home is one approach that is gaining favor. While precast and pour-in-place concrete walls have been utilized in non-residential construction for more than 50 years using this technology, into residential construction is relatively new concept. For the background research, our current issue is keycard don't give access to facilities. Second, don't have sewage system, and third is safety during disaster. For the current solution, our solution for the problem is integrate backend system enable everyone with one card. Next, transition to smartphone-based access. It's the problem to keycard don't give access to facilities. Next, solution is alternative septic system is problem solving from don't have a sewage system. And the last solution is using concrete and plastic insulation for safety and energy efficiency in building design for safety during disaster. It is the problem solving from safety during disaster.
There are 10 ideas demonstration on possible solution. Number 1, support ticket. Resident or building employees can submit a maintenance request. For example, if a van isn't providing fresh air to a specific area of the buildings, automated process can just need activating the smartphone application and reporting the issues, as opposed to phoning the facility manager. After that, this support issue is automatically added to a queue that the maintenance manager may view through a support dashboard. They then send out staff to address the issue. Number 2, work orders. By automating work orders, maintenance will be performed as promptly and effectively as possible. When work orders are automated, teams may establish workload, assign tasks, and track maintenance requests from beginning to the end while prioritizing the more critical issues. Number 3, preventive maintenance. By using this method, equipment is kept performing at a high level continually rather than waiting for anything to break. Additionally, a predictive method may be used to schedule maintenance and repairs such that the most critical system is identified by the building owner or operator. Number 4, cleaning. Healthy buildings boost occupant productivity. Cleaning up is made simpler by automation, which also extend the life of system and equipment. Number 5, system monitoring. Monitoring the function of building system is one of automation's most effective application. These have excellent opportunity to fix operational problem, get rid of inefficiencies, cut expenses, and make place more appealing for occupant if it continuously monitor how equipment works and how much energy is used. 6. Software for building management. All the building system may be combined into one software by utilizing a building management system (BMS) or centralized technical management (CTM) program, which include HVAC, security, lighting, and mechanical system. A building automation system or an intelligent maintenance management platform can also be connected to the smart technologies as previously highlighted, such as InfraSpeak. 7. Mapping the asset. The team's work is easier to complete when assets are correctly identified and mapped. Understanding where the next repair order is or where the breakdown was recorded is made considerably easier as a result. Number 8. Consider the equipment entire life cycle. It is critical to take into account all stages of an asset life in order to guarantee its ability and reliability. It is critical to comprehend the demand of the user, the design requirement, the expected quality, and the life cycle maintenance costs throughout the planning stage. Number 9. Create economies of scale. Purchasing equipment that may be used with other existing equipment to simplify operation and maintenance in another effective building management strategies. Number 10. Adapt to IoT. One of the greatest facility management techniques is installing IoT connected device and upgrading the buildings. So the conclusion is the actual value of smart building is in their capacity to create the data that guarantee understandable and provide insight. On top of that, bring those insight back to the business to improve interaction and process. Owners and operators may establish more effective operations and have better visibility into the health of the building because of smart buildings. That's all from us. Thank you.